Hello, Rockstars. We will be continuing in our physics ignition series. In the last class, we talked about work, energy, and power. In today's class, we will be advancing to another critical and very important topic, machines. And under this class today, we will split the lesson into three different sections. In the first section, we will be talking about the concept of machines, where we will define major concepts and also be addressing 7 classical simple machines. Secondly, we will be listing the formulas in machines, and lastly, we will be using these formulas to crush UTME questions. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to smash the subscribe button, turn on the notification. Let's get started. Machine is an important physical concept. Machine is a device that enables work to be done easier, faster, and more convenient. Now, to understand the term machine, we need to define certain terms in it. And the first one is the term mechanical advantage. Mechanical advantage is also known as force ratio because it is the ratio of the load, which is a force, to the effort, which is also a force. Secondly, velocity ratio. Velocity ratio is actually a distance ratio. It talks about the ratio between the distance moved by effort to the distance moved by load. And lastly, the efficiency of a machine. The efficiency of a machine is the ratio of the work done by the machine, which is called work output, to the work done on the machine, known as work input multiplied by 100%. So always our efficiency is given in percent. Our work output, remember from the last class in work, energy, and power, we say work is the product of force and distance. So work output is the work done by the machine. So work in this case is force, and the force here is our load. So load multiplied by our distance is the distance moved by load, because the work output is the work done by the machine on the load, whereas our work input is the work done on the machine. So that is facilitated by effort. So our force here will be effort multiplied by our distance will be distance moved by effort. You see it? Now, from this, our load over effort is our mechanical advantage. Remember, we said mechanical advantage is a force ratio, which is load divided by effort. So L over E is the same thing as mechanical advantage. So our distance moved by load divided by our distance moved by effort is the inverse of velocity ratio. Remember, we say velocity ratio is a distance moved by effort divided by the distance moved by load. So that means this is 1 over velocity ratio multiplied by 100. This will give us a mechanical advantage all over velocity ratio times 100%. So our efficiency is mechanical advantage divided by velocity ratio times 100%. Now, mechanical advantage is affected by friction, because when a force is applied as effort to move a load, the moving part can experience a loss of energy via friction. So, mechanical advantage is affected by friction, whereas velocity ratio, which is a statement of geometry, of distance, is not affected by friction. So, please take note. Mechanical advantage is affected by friction. Velocity ratio is not affected by friction. Thus, it makes our efficiency to be affected by friction. And that's one of the reasons why the efficiency of a machine cannot be 100%, because energy is lost via friction. Now, let's advance to talk about the 7 classical simple machines. There are 7 very important machines we will be taking note of in our class today. The number 1 is what we call the lever, or simple lever. The lever is made up of a rigid body that is pivoted about a point called the fulcrum, where an effort applied at one point causes the movement of a load placed at another point. Now, there are 3 orders or classes of lever. The first one is known as the first class lever. This kind of lever is seen where the fulcrum is in between the effort and the load. Now, before I advance, please take note that the fulcrum is actually the support around which the lever turns. The effort is the force being put in to lift the load. So the load is the body that is being lifted or moved. So now, in first class of lever, the fulcrum is in between the effort and the load. So, example of our first class lever is our scissors, our plier. If you take note of these devices, the fulcrum, the moving part is at the center, where you lay hold on it. The handle is the effort, and the thing to be caught or handled is the load. So that's the first order of lever. Now, the second class lever. In the second class lever, the load is in between the effort and the fulcrum. The load is in the center. Example of second class lever, we have our wheelbarrow. We have our nut cracker. We have our bottle opener. The load is at the center, the fulcrum and the effort are at both ends. And lastly, we have our third order, Now, our fourth class lever, the effort is in between the load and the fulcrum. An example of fourth class lever is the human arm. Imagine I want to do arm wrestling. Now, this point on that desk is my fulcrum. This that I'm applying force on, this is my effort, and the other person's arm is my load. So our effort is in between the fulcrum and what? The load. Another example is the sugar tongue. And also, we also have our fishing rod. So these are the three classes of lever. So our second classical simple machine is pulley. A pulley, a simple pulley, is made up of a wheel where a rope passes in the groove of its rim. A pulley can either be a fixed pulley that the wheel doesn't move, or it can be a movable pulley where a machine, that wheel moves. And the pulley can also be in multiples. We call that one a pulley system or a block and tackle system, where we can have as much as 3, 4, 5 or even 6 pulleys in a particular pulley system. And you know, the more the pulley, the more the velocity ratio, the more the mechanical advantage, and so the more load can be lifted. So now, in a pulley, our velocity ratio is the same as the number of pulleys or the number of rods, which is in semblance with the number of pulleys. Let's say, for instance, we have a 5 pulley system and an effort is applied at a particular point. The distance moved by that particular effort, let's say, is D, and it has 5 different pulleys. The distance moved by the load, seeing that the load is connected to the 5 pulleys, it will be D over 5. So our velocity ratio now will be D times 5 over D. D cancel D. So our velocity ratio is equal to 5. So our velocity ratio is equal to the number of pulleys. As simple as that. So if you see a question where they tell you a block and tackle system has 6 pulleys, it simply means the velocity ratio is 6. If it has 4 pulleys, the velocity ratio is what? 4. The third classical simple machine is the inclined plane. The inclined plane is actually a slopy plank that is placed on, let's say, for instance, a truck or a vehicle that is used in offloading tanks, gallons of oils down the slope, or in uploading it. So it looks like this. So this is the plank placed on the vehicle. Then you are trying to move a load either up to the truck or down from the truck. So let's say, for instance, the distance is X. The distance with which you will lift that object, let's say it is Y. This now looks like a right angle triangle, our angle of inclination. So remember, our velocity ratio is distance moved by effort divided by the distance moved by load. That means our velocity ratio, distance moved by effort. Remember, we are trying to move the body through this slope. So the distance moved by effort is what? X. And the distance moved by load, the load was formerly here and now it is here. So our height is Y. So velocity ratio can simply mean our length, which is our slant, divided by our height. So you may see some questions where they may ask you, calculate the velocity ratio of an inclined plane with length of this and the height of this. So simply know that you are dividing the length by the height. So now also note that if it's x over y, that's similar to something. Our sin theta is equals to y over x, opposite over hypotenuse. So if I will want to make y over x to become x over y, I will do the inverse of it. That means my velocity ratio is equals to x over y will be what? 1 over sin theta. Remember, sin theta is what? Y over x. 1 over y over x will give you x over y. 1 over y over x will now become 1 times x over y, which is x over y. You see it? So don't forget that our velocity ratio is length over height, and it's also equals to 1 over sin theta. The theta is the angle given here. So that's for an inclined plane. So another classical simple machine is our screw. And one of the most classical example of screw is our screw jack, where it's a machine where you see someone wheeling it at one side, and the rotatory motion culminates to a linear motion in lifting a vehicle. So this is a scenario where rotatory energy is being converted to linear energy. So in this case, our velocity ratio, which is distance moved by effort. So the person is wheeling it around a circular path. So the distance moved by effort is actually our distance of a cycle, our circumference or perimeter of a cycle, which is what? 2 pi r, with r being the radius. Then our distance moved by load is the distance screw moves from one thread to another thread, and that distance is known as the pitch. So one complete revolution results to a vertical lifting from one thread on the screw to another thread, and the distance between it is called the pitch. So we use screw jack for lifting load. Number 5, we have the wheel and axle. This is a scenario of a joined machine where the movement of one part results to the movement of another part that is attached to the load. In this case, the axle is found within the wheel. It's like a cylindrical rod found within the wheel, which is a circular disc, and they are connected by a rope that is wheeled all around them with the load attached to the axle. So the movement of the wheel results to the movement of the axle in opposite direction, causing the lifting of the load. So this machine is used in lifting loads. So in that case, the movement of the wheel results in the movement of the axle to which the load is connected to. And also, it is used in speed, in increasing speed of a machine, like seen in a bicycle, where a chain is connected to the axle, where the paddling of that bicycle results in the movement of the axle, and the movement of the axle connecting to the wheel results to the movement of the wheel. So the faster the axle moves, the faster the wheel moves, carrying the load, which is the person on it. So in this case, our velocity ratio, remember, distance moved by effort. So in the case of lifting an object, the wheel is now our effort. So the distance of our wheel, which is a circular path, because it moves in a circular path, is the circumference, which is 2 pi r, divided by our axle also moves in a circular path, and the circumference or the distance of a cycle is also 2 pi small r, because the wheel is bigger. That's a bigger radius compared to this. So 2 pi cancels 2 pi. So our velocity ratio in wheel and axle is the radius of the wheel divided by the what? The radius of the axle. Now, number 6. We have our gear. Our gear works on the same principle as the wheel and axle. Only that in the case of gear, it has edges, like a serrated edge, which we call teeth, or tooth for singular. So in this case, the movement of one part of one wheel results in the movement of another wheel. The wheel that is causing the other wheel to move is called the driver, whereas the wheel that is moving by the force of the driver is called the driven wheel, similar to the wheel and axle or a bicycle. So in this case, our velocity ratio is equal to the number of feet of the driven wheel divided by the number of feet of the driver wheel. Our velocity ratio for a gear is the number of feet of the driven wheel divided by the number of feet of the driver wheel. So as I said, just imagine these both wheels as the driver is the boss giving command. The driven is a subject or a follower obeying to the command of the driver. The driver initiates the process and the driven follows. So whenever the driver stops, the driven also stops. Just like a bicycle. When you stop paddling the axle, soon the wheel stops. So the axle is our driver wheel, whereas our bigger wheel is our driven. And lastly, in our listing of classical machines is our hydraulic press. Our hydraulic press works on the principle of pressure in fluid. This will be treated in detail when we take that topic called pressure in fluid. So a hydraulic press is used in lifting massive loads like offloading cargoes or uploading cargoes in ships. So there are actually two areas. The smaller area connected to the bigger area which has our load, and the smaller area has our effort. And connected between them is our fluid. So this works on the principle of the incompressibility of liquids. So the force applied in this area results in what the lifting of this massive load in this area. So in an hydraulic press, to find our mechanical advantage, remember, mechanical advantage is load over effort. And these both, as I said before, they are both forces. So since what is experienced here is a pressure, pressure is equal to force over what? Area. So if I am finding force now, my force is equal to pressure multiplied by area. So back to my formula, mechanical advantage is pressure multiplied by the area of the load. That's here, capital A, divided by the low effort, which is also a force. Pressure multiplied by the area of our effort. And now remember that these both pressures are the same. So pressure cancels pressure. So our area, this is actually a circular body. So our area of a circle is pi r square divided by, and for the small body is pi r square. So pi cancels pi. So our mechanical advantage is equal to the radius of the larger area divided by the radius of the smaller one. And this is also the same formula for velocity ratio of an hydraulic press. Now let's move on to the second section, where we'll be listing the formulas in machines. We've listed many of them, so let's just reiterate them. Mechanical advantage is load over effort. Velocity ratio is distance moved by effort divided by distance moved by load. And for the all other different machines, they have their own unique velocity ratio, as we have listed before. Efficiency of a machine is mechanical advantage divided by velocity ratio times 100%. Also, efficiency is work output, the work done by the machine, divided by work input, the work done in the machine, multiplied by 100%. Efficiency is equals to, don't forget, load times distance moved by load all over effort multiplied by distance moved by effort times 100%. So these are the most important formulas you need to know: mechanical advantage, velocity ratio, and efficiency of a machine. So now, can we go and crush UTME questions? Come with me. So the first question, An inclined plane of angle theta acting as a simple machine has a velocity ratio of, we already know that the velocity ratio of an inclined plane is what? 1 over sine theta, which is equivalent to the length divided by the height. So our answer is what? B. The next question. Which of the following machines does not apply the lever principle? So what's the lever principle? It means it's a rigid body that is pivoted at a point called the fulcrum, and it has a load and an effort. So a claw hammer, if we can still recall, a claw hammer is first class lever. Our wheelbarrow is second class lever. Our sugar tongue is third class lever. Our nutcracker is second class lever. So the four of them are classes of lever. They both have fulcrum, load, and effort. But our simple moving pulley is a different kind of machine altogether. So our answer is what? Simple moving pulley. The next question. A block and tackle system has 6 pulleys. If the efficiency of the machine is 60%, determine the mechanical advantage. So let's go straight to write down our data. It has 6 pulleys. Remember, we said for a block and tackle system, the number of pulleys is the same as our velocity ratio. An efficiency of 60%. And we are being asked to find our mechanical advantage. Our formula. Efficiency is equals to mechanical advantage divided by velocity ratio times 100%. So let's substitute our data into our formula. Our efficiency is 60. Our mechanical advantage is our unknown. Our velocity ratio is 6 multiplied by 100. So this will give you 60. MA times 100 will give you 100 MA divided by 6. So you cross multiply. This will give you 360 is equals to 100 MA. So divide both sides by 100. So our mechanical advantage is equals to 3.6. So our answer is C. Please take note, for mechanical advantage and velocity ratio, there is no unit, because load is in Newton, effort is in Newton, so they will both cancel themselves. Same for velocity ratio, meter, distance over distance, so they will both cancel themselves. So, to the next question. In an ideal wheel and axle system, capital R stands for the radius of the wheel and small r is the radius of the axle. The mechanical advantage is, now please take note of those words, ideal wheel and axle system. In real sense, in practical sense, there are no ideal, because there is always friction. So for an ideal wheel and axle, the mechanical advantage equals to the velocity ratio. And if you can still recall, is 2 pi capital R divided by 2 pi small r. So 2 pi cancels 2 pi to give us a capital R over small r. That means our answer is what? A. So please take note, for an ideal means the efficiency is equal to 100%, which is not realistic because of the presence of friction. So if our mechanical advantage is equal to our velocity ratio, so our efficiency will give you exactly 100%, which is not true. So in that case, our mechanical advantage is equal to our velocity ratio, which is equal to what? Capital R over small r. So the next question. A machine whose efficiency is 60% has a velocity ratio of 5. If a force of 500 Newton is applied to lift a load P, what is the magnitude of P? So what they are asking you, we are finding load. So let's write down our data. Our efficiency is 60%. Our velocity ratio is 5. If a force of 500 is applied, that's our effort, is a force applied, which is 500 Newton. To lift a load, our load is what we are looking for. They call it P. Formula best suits this. I think our efficiency. Efficiency is equal to mechanical advantage over velocity ratio multiplied by 100%. So, if I can be able to get my mechanical advantage, I will get my load. So, remember, efficiency is equal to mechanical advantage is load over effort divided by velocity ratio times 100%. So, our efficiency is 60. Our load is P. Our effort is 500 divided by velocity ratio is 5 times 100. So I will be jumping steps for the want of space. So this will give me 300 is equals to 100p over 500. So this will cancel this. So our P is equals to 1500. Now this P is what our load. So it is in Newton. So our answer is 1500 Newton. D. To the next question. Calculate the velocity ratio of a screw jack of pitch 0.3 cm if the length of the tummy bar is 21 cm. So this question is straightforward. The velocity ratio of a screw jack is what we have been asked. So our data, our pitch is 0.3 cm. The length of the tummy bar is the same thing as our radius. The tummy bar is what is being held. So the length is our radius, which is 21 cm. We have been asked to find our velocity ratio. In this question, this centimeter to meter or not, it will give you the same answer. The reason is because velocity ratio is 2 pi r over pitch. So they will still cancel themselves because of there is distance up and distance down. So if you choose still convert it to meter, this will give us 0.003 meter. Dividing it by 100. The same thing here. Dividing it by 100 will give us 0.21 meter. So let's use our data. Velocity ratio is equals to 2. So from our answers, pi was not substituted. So let's leave it as pi. R, our radius is 0.21 divided by our pitch, which is 0.003. This will give you 0.42 pi over 0.003. So if you divide this, you will get 140 pi. So our answer is what? D. Now let's take the last question. The efficiency of a machine is 70%. Calculate the work done in using this machine to raise a load of 100 kilograms through a vertical height of 2 meters. Take G as 10 meters per second square. So before we explain anything, let's write down our data. Our data will speak for itself. Our efficiency is 70%. We are asked to find the work done in using the machine. That means work done by the machine. That's work output. Don't forget, work done on the machine is input, work done by the machine is output. So we are finding work output. To raise a load, our load is 100 kg. Through a vertical height, our height is 2 meters and our G is given to us as 10 meters per second. So please, this is a kind of question that certain data are placed there but are not useful. There are many questions where you will be asked and certain data placed there are just meant to test students if they know what they truly need. So they're asking us to find work done, and we know from our previous class in work energy and power that work done, which is in this case work output, is force multiplied by distance. Our force here is load multiplied by distance moved by load, if you can still recall. So our load times distance moved by load. So remember, our force is mass times acceleration, or if the body is experiencing gravity, that's acceleration due to gravity, g. So now our work output will be what? Mass multiplied by gravity multiplied by our distance moved by load, mgh. Our load was given to us in kg, so that means it's mass. If it is given to us in Newton, it means it's force, but it has not been converted to force yet. So our mass is 100, our g is what? 10, and our distance moved by load is our height, which is what? 2. So this will give us what? 2000 joules. So our answer is what? A. So you see, we don't actually need this efficiency unless if we were given work input. Future rockstars. In the class today, we talked about concept of machine, where we define key terms in machine. Then we advance to talk about 7 classical simple machines, and we advanced to the second section where we talked about the formulas in machines, and lastly we solved some questions using these formulas. You can go and try, and you will find out that all the questions in machines, you can solve them. If you gain something from this video, please do well to smash the subscribe button, hit the like button, share, comment, and in the next class we will be treating Newton's law of motion. You can't afford to miss that class. So please do well to hit the subscribe button so you will be notified when we drop new videos. I remain your host, Josh White, living to catch you another day. Shalom.